rod is kind of short. You could use the normal one. And turn on the vacuum. The solubility of this product is very low in water, so I'm not worried about the temperature of the water that I'm washing the product with. If the solubility is even moderate, I have to use cold solvent. Just washing the stirring rod, trying to get the most of the crystals back into my Buchner funnel. The procedure tells us we want to make sure that the solution, the filter is not basic anymore. So I'm not going to test this filter or this filter, because if it's basic, it doesn't tell me if the compound still contains some sodium hydroxide. I can just use the fresh filter. For the fresh filter, I can detach the vacuum and use a drop of this liquid, the fresh filter that is coming out. Still is basic, and because it's basic, I'm going to continue washing with water. And 50 milliliter kind of sounded good because it fills up the funnel. And I would use 50 milliliter at the time and continue washing until it's not basic. So now I have a normal stirring rod. I can mix it carefully without touching the filter paper, because if I touch the filter paper, it can damage the filter paper. And if I do damage the filter paper, the crystals are going to go past the filter. All it takes is just wash with more water, and since I can touch without removing the funnel, the crystals with the pH paper still is blue. So I will continue washing. At the end, I would tell you how many times I washed with 50 milliliter, or about how much water was used to remove this, so you have an idea. Okay. And on purpose, I want to fill this up and see what happens. The liquid is going to go to the trap. If we didn't have the trap, it would have gone vacuum into the vacuum pump, which is downstairs in this lab. The trap now is filled up with the liquid, and that is not safe for our vacuum pump. It was a dangerous and high risk, but I closed it right away. So what should I do now? Remove the flask, detach the vacuum, and empty the flask again. You can do this a few times. Just be patient with this. 5 times washing, going for 6 times 50 milliliter. And at the beginning, I also add some water to the flask to transfer. Okay, it's neutral. The color is matching the neutral. So we are going to stop at this point. It's not blue anymore, it's green. And we are going to stop washing the product with water. So we move to the next step. And based on the procedure, we are going to use to catch this in the video. If we just bring it closer, see, we have a green color that does match with 7. Okay, green color. If it was blue, you could have seen it. Like, this is the blue color. So you can compare this to, see, that was basic and this is neutral. with comparison is easier to see. Next step is washing the crystals with cold ethanol. So I place the ethanol in ice bath to cool it down. For the class where more people are using or more ethanol is used, we can put like a container of the ethanol in the ice bath, but it's just for one group here. I'm going to use 20 milliliters of the ethanol. Washing product with the ethanol is going to remove any leftover of the benzaldehyde. Washing with water, it would remove any water soluble. That could be the acetone, if it's unreacted acetone, or sodium hydroxide is all removed. So this can make sure that there is no leftover of the reactant. I'm going to do washing with the ethanol 2 times. I want to make sure that there is no water left over, so I'll replace with ethanol. It's going to help me with the drying of the product. So the drying of the product now, the oven should be set anywhere between like 80 to 83, I should say, 80 degree, which is higher than boiling point of the ethanol, but much lower than the melting point of my product. The melting point of the product is literature value is around 110 to 111. And when you read the lab manual, it says that this is, if you get the product, the melting point of the product anywhere between 80 to 120, that means that you do have the product. But if it's lower than 110, that means the product is not dry properly. Because if you get benzalacetone instead of the dibenzalacetone, the melting point is not going to be in the range of 80 to 120. So that's just the approximate number. But the literature value for the melting point of this product is 110 to 111. Okay. Going to run the vacuum 2 times washing with 20 milliliters of ethanol, 6 times washing with at least 6 times washing with the 50 milliliter of water, testing with the pH paper. Now all is done. Running the vacuum for additional 3 to 5 minutes, and this is just the purpose of this extra vacuum time is to remove all the liquid, and that is going to help us help the crystals to dry faster in the oven. After the sample is transferred to the oven for like 5 minutes or until it's dry, we measure the melting point of the product, we measure the mass of the product, and also we determine the IR spectrum of this product. I want you to watch the pre-lab discussions carefully for this experiment, because there it shows the structure for the product, and the CO double bond in this product is going to be super conjugated with like multiple pi bonds on each side of the carbonyl group, and conjugation lowers the frequency of the IR peak in the IR spectrum. So if the CO double bond has or shows a peak around 1700 for normal ketone that is not conjugated, for this conjugated or super conjugated CO double bond is going to go as low as like 1650, 1648, but the IR spectrum that would be provided is going to show you the exact location for this specific product, which you can use that number to argue or defend your case that, yes, the product has formed and this product is dibenzalacetone. Okay. So the 5 minutes vacuuming is over. Now we transfer the crystals with the filter paper to the watch glass. As I said before, you can just flip it over to make sure that the paper with the crystals is going to be transferred to the watch glass. This is the same watch glass that we weighed before. And you might see now the crystals are kind of dry because we washed it with ethanol a couple of times. They are not wet with water. So it's good, it looks good. That's all I'm trying to say, that these crystals look good. And I'm going to transfer everything. I'm using like a spatula for this to transfer all the crystals and take the watch glass, pre-weighed watch glass and pre-weighed filter paper with the crystals we place in the oven that is set at 80 degrees. Okay, the oven is set at 80. It shows 81, but it's okay as long as it's not too close to the melting point of the product. We don't want to melt our product here. We're going to wait for 5 minutes for it to dry, and then we measure the mass and melting point. In 5 minutes already, going to take the sample, and the paper looks crisp, and that could mean that it's dry. If the paper is moist, definitely is not dry. So we're going to measure the mass. It's there, 54.334. 54.334, that's the mass. And now we are going to measure the melting point. We're going to measure the melting point. As I said, the literature value is 110 to 111. By tapping the open end of the capillary tube into the sample, I got some of the sample into the capillary tube. To bring it down, transfer it all the way down, passing through the hollow glass tube. Perfect. When we make the sample, we're passing through the glass tube to make sure that it's packed properly and there is no air trap. Now we place the sample into sample holder, and we are going to set the power regulator following the charts provided. The expected number is between 110 and 111. So that kind of falls between 100 and 150. The setting should be between 4 and 5, but closer to 4 in this case. Now we're just going to set it at 4 and wait for sample to melt. It's very hard. We tried so many times and it's not easy to focus for us to see in the camera the melting. So I don't want to miss the melting, so I'm going to focus here. Okay, the initial melting is almost approaching, and the temperature shows around 106, 107. Okay. Initial melting of 107, and the final melting of 109. So initial melting 107, final melting 109. It's close enough to the literature value. At the same time, your thermometer could be not calibrated, or if it doesn't match exactly with 110 to 111, some leftover of the solvent or impurity could be associated with that. So we are using mass for percent yield of the product. You use the melting point for one of the, confirming that we do have the product based on the literature value. We also turn in the sample. Students are going to turn in the sample for the IR spectrum. I'm going to include the picture of the IR spectrum as part of this video. So you would use the IR value. The peak that I'm more concerned for you to write the report based on is the location or the frequency that the peak for a strong peak would show for CO double bond is expected to be shifted to lower number from its original place that is 1700 to 1650. So look for a strong peak in that region, because based on the melting point, you do have the product. Based on the color, you do have the product. So the IR should match with that. And write a good report. Thank you.